Precipitates.
Alright. So the first thing you're going to do, you've got your chemical formulas and your word equation, or your words of the chemicals. So it might actually pay to write it out in word format. So you can go barium, you can stand up if you need to, barium sulphate plus hydrogen chloride makes, what's the first compound that will make? Barium what?
Hydrogen.
Chloride.
Chloride. Got it the front of it and the back of the other one. Remember that's positive, negative, negative. It can only combine with a positive and a negative. So barium chloride plus, wish I'd written it so small, sulphate. Good. So we've switched partners. Now we're going to write out the chemical formulas for each compound. So barium sulphate. I'm going to put brackets around that one just for safety. Plus hydrogen chloride makes barium chloride, hold up, plus hydrogen sulphate. Now I've just made two new compounds, so I need to check that I've got the chemical formula right. To do that, I will look at my valency table and I will find the following information. Right, that's what I would have got from my valency table. Barium chloride, 2 plus, 1 minus. Is that the correct chemical formula?
No.
What do I need to do?
Put 2 on chloride.
Good, I need 2 of those to make that equal to 2 minus, so the overall charge is neutral. Rub those out. Hydrogen sulphate. Hydrogen is 1 plus, sulphate is 2 minus. What do I need to do?
Add 2. Yeah, 2.
2. I need 2 hydrogens so that the overall is 2 plus, cancels out the 2 minus. That's the first step. Now that I know that my chemical formulas are correct, I need to balance it. So I'm going to do my longhand version if I need to, or shorthand if I'm okay with it. Let's list the elements. Great class here. Barium, I'll start you off. What else?
Sulfur.
Sulfur, good.
Oxygen.
Oxygen.
Hydrogen.
Hydrogen.
Chloride.
Chlorine.
Oh.
We're talking elements now. Then I go and list them all in the same order. Connor, this will be new because you haven't done balancing equations yet, but you might be okay with it. Right, then we add up our atoms. How many barium?
1.
Sulfur.
1.
Oxygen.
4.
Good, the 4 is only for oxygen. Hydrogen.
1.
Chlorine.
1.
Barium.
1.
Sulfur.
1.
Oxygen.
4.
Hydrogen.
2.
Chlorine.
2.
Could you just put it 2 in front of the hydrogen chloride?
That is exactly what you need to do. So that's okay. How do I fix the hydrogen? I put a big 2, fixes that, also fixes that, balanced. Get rid of that working. Now I'm going to use, I know that I created a precipitate. So I'm going to use, on your prac sheet, Ollie and Jai, actually Jai has a question.
No, I have to go because I have to go do something for my work experience.
Okay.
Thank you.
Work on your prac report, see the dash for instructions.
Yeah.
Okay, on your prac sheet you'll see the soluble or not. These are the solubility rules. So they actually govern what things should dissolve in water and what things should not. So you will be using, Ollie Lindsay, you will be using those rules to work out which one of these 2 new chemicals actually formed the precipitate. Okay, so we know that these 2 were soluble in water. So what subscript do I write there? AQ for aqueous, dissolves in water to form a solution that looks like water. So AQ. Then I need to look here and go, all right, let's go through my rules. The first rule is that all compounds containing either sodium, ammonium, potassium or nitrate ions will dissolve in water. We've got none of those. Next one. Compounds containing the chloride, bromide and iodide ions are soluble except when they contain silver, lead or mercury. Do we have any of that? Chloride. So we know, one moment. Why do I always pick an example that doesn't follow the rules properly? So let's say no, because it contains chloride and it's not an exception. Then over here, sulphate. Compounds containing the sulphate. Oh, wowzers. Compounds containing the sulphate ion are soluble except for barium sulphate. Oh, I don't know that. Except for barium, lead and calcium sulphate. So that is a perfectly rubbish precipitate reaction. Remember, however, when I said some of the solutions that we have in there are a bit suspect in terms of their solubility. So they give us sometimes compounds that actually don't dissolve all the time, especially at certain temperatures. I would suggest, and you would have made notes about it, that the barium sulphate solution that you were using possibly looked a bit cloudy. Agree?
Yes.
And so what you were seeing in your reaction, in fact this is perfect, what you were seeing in your reaction is that you thought you got a precipitate, but you didn't. It was coming from the original one which wasn't fully soluble. It gets a bit fussy. So what you do is you use the rules to determine whether your crack results were right. In this instance you would go, what? No, these couldn't have produced a precipitate. However, this one's a bit of a funny one. On the day it might have been a bit cloudy and so I looked at it and thought I had a precipitate but I didn't. But it was actually that solution that already precipitated out. Thank you.